We're going to be talking about recursive formulas today, and this is something that always really trips up or messes up my students, and I think it's just because there is a lot of letters here, and when we see a lot of letters we kind of freak out and we're like, oh my gosh, what's going on? But let me tell you, I'm hoping by the end of this video you feel a lot more comfortable and confident with recursive formulas, because really all you have to do is look at the end of the formula to know what's going on, okay? So what you're seeing on the screen in front of you is two different recursive formulas, one for the arithmetic sequence and one for the geometric sequence. What you'll notice is that the very beginning part for both of them are exactly the same, okay? The only thing that's different is this ending value right here, okay? And the D being the common difference and the R being the common ratio. And the A here represents the first term. And the reason why it represents the first term is because of this f of 1. If it was any other number here, like f of 2 or f of 3, then it would represent whatever that term is. So essentially what the recursive formula does for us is it tells us what the pattern is for the sequence. So what am I adding every single time? What am I multiplying every single time? And then it gives us a specific term in the sequence. And usually that specific term in the sequence is the first term. Okay, so we're going to look at a few examples here, and we're going to look at interpreting the formulas and then how it's used in different contexts. Okay, so let's look at this first example. So example 1, we have f of n equals f of n minus 1 plus 5 and f of 1 equals 8. Now, at first glance, you're like, wow, that's a lot of letters, a lot of things going on. Like, what the heck am I looking at? This first part right here is just saying, hey, the function is going to take the previous term and add 5 to it. Okay, so the function is going to take the previous term. So this f of n minus 1 represents the previous term. And then we're going to add 5 to it. So this right here is the common difference. So our d is equal to 5. We're going to add 5 every single time. So that's our pattern, plus 5, plus 5, plus 5. And then the bottom portion here, it says f of 1 equals 8. Well, that's the first term. So my first term is 8. So if I started with 8 and I added 5, I would get 13. Then I could add 5 again and I get 18, and I could add 5 again, and I could keep on doing this every single time and create my sequence, okay? Now, example 2 is pretty much the same exact thing. The only thing that's different is you'll notice that instead of a plus 5, we have a times a half. So times a half. And I apologize, this f of n should actually be f of 1. I'm so sorry about that. Okay, so times a half here. So it says, what is the common ratio? Notice the different key vocabulary that's changing here. When we say ratio, we're talking about a geometric sequence. When we see difference, we're talking about an arithmetic sequence. So we're timesing by a half every single time. So our common ratio or our pattern is times by half. Or if you want to use it in division terms, divide by 2. But remember, we can't use the division symbol in regards to our recursive or our explicit formulas, so that's why we put times a half, okay? Now, what's the first term? 16. So I can learn that because it says f of 1 equals 16. So my first term is 16. So if I took 16, I multiplied by a half, which would give me 8. I multiply 8 by a half, which gives me 4. I multiply 4 by a half, which gives me 2. I have the start of my sequence. So to recap, example 1 sequence is 8, 13, 18, 23, and so on. Sequence or example 2 is 16, 8, 4, 2, and so forth. Okay, so we continue to either divide by 2 if you want to think of it in that terms, or multiply by a half. Okay, so now let's look and see how these look in a different context. So here we have 3 different types of examples. So we have a table, we have a graph, and then we just have a sequence laid out. And what the question is what is the recursive formula? So the first thing that we need to do is we need to figure out or establish what our pattern is. Okay, so what's occurring every single time as we go along? Are we multiplying? Are we dividing? Are we adding? Are we subtracting? So if we looked at this very first example, so let's call this first example A, okay? So how do I get from 80 to 20? Your first thought might be, okay, well, I subtract 60. Well, if I continue to subtract 60, I'm not going to get 5. So let's look at in the terms of division. So I could divide by 4 here. Now, remember that when we talk about division, in our recursive formula, we can never keep it as division. So divide by 4 also means multiply by 1 over 4. So if we divided by 3, it would mean times by 1/3. If we divide by 2, it would mean times by 1 over 2. Okay, and we want to make sure that that's consistent all the way through. So if I did 20 divided by 4, I will get 5. 5 divided by 4, I will get 5 over 4. And so if we wanted to write a recursive formula, our beginning of our recursive formula always starts off exactly the same way. So you have f of n equals f of n minus 1, and then, I'm so sorry, not an equal sign. And then we're going to put our pattern here. So I'm going to change the color here. So our pattern is times by 1/4, okay? And then the last thing we want to do is we want to put what is our first term. So we can clearly see in the table our first term is 80. So we're going to go ahead and put 80 there. And voila, you have the recursive formula for the table. So all we had to do was input in what is the pattern and what is the first term, okay? Now we're going to do the exact same thing for our table and for our sequence. And what I'm going to do is I'm going to write in the beginning portion of our recursive because it's going to be the same every single time. The only thing that's going to change is going to be what is their first term and then what's the pattern. So for this last one too. And remember, this stands for f of n equals our previous term, and then what are we going to do with our pattern? Okay. So if we looked at this graph, we could start if you feel more comfortable with the first term. So we can see that our first term is 2 here. Okay. Now what we have to do is we have to figure out what is the next term, what's the term after that, what's the term after that to help us figure out what is the pattern. Now one thing that you should notice is that these lines create a straight line. So if I connected them, it would be linear. So that's going to give us a heads up that we're dealing with an arithmetic sequence, meaning that we're going to add or subtract a constant. Another thing that you might notice is that it's going in an upward direction, which means that we're going to be most likely adding and not subtracting. So I'm going to be putting plus here. So I have to see, okay, the first term is 2. How much is it going up and over? And this one, it looks like it's 5. So it looks like it's plus 3. So let's see if that's consistent. I'm going from 5 to 8. Yep, that's plus 3. And I'm going from 8 to 11. So yep, that's plus 3. So our pattern here is plus 3, or our rate of change is plus 3. Okay. Now let's look at this next one. Next one, kind of the same thing. We're going to see how do we get from one term to the next. So from 21 to 16, I minus 5. Let's see if that stays consistent. 16 minus 5 is 11, and 11 minus 5 is 6. Excellent. So our pattern here is minus 5. Our very first term, which is our f of 1, is going to be 21. And now we have our recursive formulas. So again, regardless of what form you're in, the first thing you want to do is look for the pattern and look for key traits that will help you figure out whether it's arithmetic or geometric. Okay. And then the second thing you want to do is find the first term. Now, again, kind of like I showed you before, if you feel more comfortable with identifying the first term first before you do the pattern, go for that as well. Okay. I'm going to do one more example problem that's a little bit different. It uses the recursive formula to help you find a different term in the sequence. And there's 2 different ways for you to do this, okay? So I'm going to start with the first way for the first term. So this is example 3. Here we have our recursive formula. We're given our first term is 29 and our pattern is plus 7. So we want to know what is the fourth term. So one way we can do this is we can just start with the first term and continue on. So what is 29 plus 7? Okay, that's 36. So this would be my first term. This would be my second term. I need to go all the way up to my fourth term, okay? So 36 plus 7, I have 43. That's my third term. And then 43 plus 7 is 50, and so that would be my fourth term. So an option here would be to just continue the pattern to get the next term, okay? Another option for you is you could write the explicit formula and then figure out what term you're looking for. Now, I know that we're doing recursive first. Just know that that is an option for you if you would like to do it on the later videos, because again, I have not explained how to do the explicit formula yet, okay? So if we looked at this next one, we know that we're gonna be timesing 3, and our first term is 2. So if I times by 3, I get 6, and if I times by 3, I get 18, so my third term here is 18. So again, just another way for us to use the recursive formula to help us figure out different aspects or situations for our sequence unit. I hope that you learned some information in regards to recursive formulas, and I also hope that they're not as scary as we usually think that they are. I will look forward to seeing you guys in our next video session, and until then, have a great rest of the day.